Hey everyone, welcome to Cloud Hero. All right, my name is Samir Trivedi. I am the DSC lead at Virginia Commonwealth University. Now, after this workshop, we'll be answering any questions about how to get more involved with our university chapter. And if you guys have any questions, we will answer them later on. Now, furthermore, I'd like to welcome Eric.
Hey everyone, my name is Eric Stein. I am the DSC president at the University of Virginia, and I'm happy to be here today. I would like to welcome Ryan Matsumoto.
Hi everyone, my name is Ryan. I am a developer advocate at Google, based in the San Francisco office, and welcome to Cloud Hero. We're super excited to have you all here and to introduce you to Google Cloud and all the amazing things you can do with our solutions and products.
All right, so here's what we're going to be doing today. We're going to learn more about the game itself and why we're playing it. We're going to hear from Ryan about some relevant solutions and possibilities in using it. And we'll move on to how to play and how to set up the lab in a little bit. Now, after we've created a Quick Labs account and we enter the campaign code, let the games begin. We'll close out the workshop with some pro tips to assist you in the other 3 labs, and we'll also have a quick Q&A session at the end if anyone has any questions. Now, what is cloud? What is cloud computing? It can be a confusing term, but at the most basic level, it means that we're getting things done using someone else's computers. The definition you read here is definitely not cloud computing. Google Cloud Platform allows us to use Google's computing infrastructure to help us run our own applications. Now, does anyone know where this photo is taken? This is one of Google's many data centers, which house computing, storage, and networking resources that power Google's own products and services. This specific center is in Council Bluffs, Iowa. When you use Google Cloud Platform, you're using a slice of one of these data centers to power your own applications. Now, what is Google Cloud? Google Cloud is a suite of secure and innovative ML and storage, powerful compute, and integrated data analytics products and services. Now, Google Cloud, how do you build the skills to get the most out of these technologies? You'll have to take a new approach. Equipping your team with the right skills can make or break your journey in the cloud. Traditionally, IT training has been centered around one piece of technology, but cloud technology requires a new way of learning. It is no longer about learning and operating that technology. It requires a change in mindset. Google Cloud Training helps you understand how to use the technology within a job function to build cloud solutions that drive cross-functional success. We have role-based learning to help your team thrive in a cloud-first world, to help them move from maintainers to strategists, innovators, and disruptors. Now, on to Eric.
Wondering, what is Cloud Hero? Why am I here on a Saturday? So, Cloud Hero is a virtual hands-on training event using the game functionality on Quick Labs to help technical practitioners gain skills through interactive learning in a fun and competitive environment. Cloud Hero brings developers together to compete against one another in gamified labs by using their Google Cloud skills. And it's one of the many interactive products from the Higher Education Learning Center from Google Cloud. And overall, using Google Cloud will put you on the right path towards gaining perks and certifications. So here's an overview of the labs that are included in today's game, Data and Machine Learning with BigQuery. We'll get started by doing BigQuery, Quick Start, and Command Line together, and then you'll be able to do the rest on your own. And each of these labs is a building block. So once you pass one of them, for example, you'll be more prepared to tackle the rest of them and on your way towards getting a virtual badge. So what is the Higher Education Learning Center from Google Cloud? It's a center that provides students, faculty, researchers, and IT admins with cloud credits, professional certifications, and ready-made learning content. And most of these benefits can actually be claimed at no cost and do not require a payment method. So to see if you're eligible and claim your benefits, go to g.co/learncloud/programs. Yeah, so what are skill badges? Participating in workshops like Cloud Hero, along with other labs, allow you to earn skill badges, which help you gain hands-on experience from real-world, and you can learn real-world skills on the Google Cloud Console using Quick Labs. They help you demonstrate in-demand, industry-standard skills that prove to employers that you know what you're doing when it comes to Google Cloud. And they also help you share your accomplishments with your network, be it on your resume, your social media, anywhere. And by completing this game, at the end, you'll be faced with a final assessment challenge lab. And once you pass that, you'll have your skill badge. So here's a quick little brief overview of the multiple skill badges you can potentially earn. There are skill badges for many different learning paths, such as infrastructure, application development, network and security. But today we'll be focusing on data, machine learning, and AI. And this cloud here will be step one towards gaining all of the badges in that category. So why is this important? Why are collecting skill badges so important? Well, skill badges help you gain practice and training for the Associate to Cloud Engineer certification. How cool is that? Just by playing some games on a Saturday, you can be well on your way towards gaining a real Google certification. And if you're interested in these types of events, feel free to scan that QR code over there so that you can stay up to date with the DSC at UVA events that relate to this, since we'll be hosting a lot more Cloud Hero events throughout the year. So I hope to see you there. And now, to help me introduce the rest of the game, please welcome our Googler, Ryan Matsumoto.
Hey everyone, thanks Eric. So let's see. So now that you have a foundational knowledge of Google Cloud, let's learn a little bit more about machine learning on Google Cloud. So let's consider an example problem of distinguishing between photos of puppies and photos of muffins. So one really simple way to go about this would be to set up a very simple check to see whether or not there are eyes in the photo. And if there are eyes, we could label a photo as a puppy photo. And if there aren't eyes, we can label it as a muffin photo. But sometimes it's not going to be so easy. So now our rule for looking for the eyes doesn't work because we have those blueberry muffins, and the blueberries look a lot like eyes. So this shows us that using hard-coded rules will only take us so far in helping us to classify these two images. So we're going to have a more complex approach. So here's another sample problem to take a look at. We have this sentence here: the brown quick fox jumps over the lazy dog. So does anyone know what's special about this sentence? So this sentence is special because it has every single letter of the English alphabet from A to Z. But does anyone actually know what's wrong about this sentence? So you might have noticed that instead of the brown quick fox, it should actually be the quick brown fox. And chances are that you basically just sort of knew that intuitively. And the reason for that is that we have these syntax rules for adjective order in English. With multiple adjectives, they need to be in the following order: quantity, quality, size, age, shape, color, proper adjective, and purpose or qualifier. And what's cool about this is that chances are you don't really know these rules explicitly. You just sort of know them subconsciously. And the reason for that is that you learn them over time by observing patterns, by observing how people talk or how words appear in books. And eventually you pick up on these patterns and you start to internalize these syntax rules without ever having to explicitly memorize them yourself. And that's sort of similar to the general process with machine learning. So machine learning is learning from rules plus experience. Here's a nice diagram showing how machine learning differs from classical programming. So with classical programming, you take as input your data and the rules, and you apply the rules to that data to get your answers. But with machine learning, it's a bit different. Your inputs include your data and the answers for that data, and you sort of work backwards to figure out what the rules are. And then you apply those rules to new pieces of data to help you evaluate those pieces of data. So what is machine learning? One definition from the IEEE organization is that machine learning is using data to answer questions. Sorry. The IEEE definition is that machine learning is a study of computer algorithms that improve automatically their experience. The other definition from one of my colleagues at Google is that machine learning is using data to answer questions. So with machine learning, we generally have a three-phase process. So the first phase is data collection. The second phase is model generation, and the third phase is prediction. And as our model takes in more data over time, it can generate more accurate predictions. So our machine learning model is continually improving as it observes patterns in new pieces of data. So ML teaches a computer to make repeated decisions using standard algorithms and lots of data. And the data really is the key here because having more data allows us to generate a more accurate machine learning model that improves as we go along. Machine learning is used a lot at Google for different Google products. So has anyone used the Google Photos app? So one of my favorite features of Google Photos is the keyword search. So you can search for all the photos in your collection that are photos of dogs or photos of Hawaii, and then all those photos will show up. And Google Photos uses computer vision technology to label different photos based on what Google's machine learning model thinks is going on in each photo. And after training the machine learning model on billions of images, Google Photos has a really accurate predictive model to allow you to figure out what's going on in each image. Another example of machine learning at work at Google is with Gmail Smart Reply. So you might have noticed that Gmail will actually give you some suggestions for how you might want to reply to incoming emails. And these replies are generated using machine learning with natural language processing technology. So obviously a lot of machine learning going on at Google with Google products. One of the big challenges with AI and machine learning in the industry today is that although it's really powerful, very few people actually have the experience to build really great custom machine learning models. And one of Google Cloud's big goals recently has been to empower more developers and more users to put AI into production. So we want to democratize AI by making it easy, fast, and useful for all developers and users, regardless of how much experience you have with ML. So one product that we're going to highlight today in this interactive workshop is BigQuery, which is Google Cloud's big data database. BigQuery lets you store and retrieve large data sets. And you can query these BigQuery data sets using mostly standard SQL syntax. There are a few differences, but you can look them up if you need to. BigQuery also has a lot of really great free public data sets that are available. So for example, we have COVID-19 data sets for things like case counts, mobility, demographic data sets, and economic data sets. We also have some other cool data sets like the NCAA basketball data set. So that's really great if you want to look up statistics about past tournaments and past games. And we also have city-specific data sets. So these are data sets about different cities and things that are going on in them. So cities like Seattle, Los Angeles, Chicago, New York City. So statistics about public transportation, bike usage, and a whole lot more. So BigQuery is accessible via the Google Cloud Console, which is the web portal where you can manage your cloud resources. But you can also access it via your code using our client libraries, which we have for a whole bunch of different programming languages, including Python, Node.js, and Java. So now let's take a look at this video about how students in Los Angeles use Google machine learning products to identify potholes.
Hello, my name is Alejandra.
And I'm Erickson.
And we're using machine learning to find potholes on the streets of Los Angeles.
LA has over 7,400 miles of roads and freeways.
That's a lot of roads and a lot of potholes to fix.
Right now, construction workers have to manually inspect roads for dangerous potholes and cracks, or rely on people calling in tips, which takes a lot of time.
While studying at LMU, we started to see if we could figure out a faster way to identify potholes throughout the city.
First, we needed data. So we rigged a camera to a car and we drove around to capture footage of different roads and freeways.
Then, we used TensorFlow, Google's open source machine learning tool, to develop a model that could quickly identify potholes, road cracks, and other weird stuff with a high rate of accuracy. Which means workers can spend less time finding potholes and more time fixing them.
So a lot of really cool stuff going on here. And as you can see, even as a student, there's a lot you can do with Google Cloud to help to solve for challenges in your community. So now we're going to go ahead and get started with the interactive hands-on lab. So go ahead and take it away.
All right, now let's get started. So now, first of all, please everyone switch onto an incognito window. You'll find that everything goes a lot more smoothly. Most of your issues should actually be fixed by this. By the way, Chrome browser works the best for quick labs. Firefox is next, and if you don't have either of those, any browser should be fine. Now, please create an account or assign into Quick Labs. This is our hands-on lab environment where we will actually be in the live Google Cloud Platform ecosystem. All right, I'm going to wait a few seconds for everyone to go ahead and do that. Okay, now, if anyone needs to change their language, this is how you can do so. If anyone needs to go ahead and take a screenshot of this or a picture, and a few more seconds for everyone to get that. And now we can move on to the next one. Please make sure you pick a family-friendly name. First and last name is good, just so we know who the winners are at the end. All right. Now, onto the game link. So here's the game link. Go ahead and copy and paste that into your incognito window. Also, go ahead and copy that code into the pop-up that shows up once you've entered this the game. You'll be granted access into 4 labs and game. Now, once you enter, this is what you should see, for example. I'm going to wait a few seconds for everyone to get to this page. All right. Now, this is the game. It has 4 labs, and what is the game actually exactly? It is data and ML with BigQuery. It has 4 labs. After this workshop is complete, you'll have to finish the remaining 3 labs in order to gain your actual Cloud Hero skill badge. And each time that you use this system, it will require an anonymous set of credentials to make sure you don't get confused with other students or their project IDs. If they do get confused, then you may not be able to complete the exercises and the subsequent labs in order to keep everything straight for each lab. This is exactly why we're using an incognito window, actually. Now, very important, make sure at the start of each lab, you will get a new login. So you must end the previous lab in order to move on to the next one. And there we go. Make sure you end the lab to move on. Now we're getting ready to begin. I hope everyone is ready. A friendly reminder that this portion of the workshop will be recorded as a reference to the other 3 labs. And one more pro tip. So make sure that the project ID is the correct one that is the current lab you're working on. This is the alphanumeric label that you need to copy into the verification field in the Cloud Hero game console to validate your project. Once you've copied that number, switch back to the Google Cloud Hero game tab in your browser. And now on to Eric for the live demo of the game.
Hey everyone, so let's play. So one final thing before we begin, just to mention about timing and scoring. Points are earned by completing the steps of the lab in order, and bonus points are earned for speed. So you're being graded based on accuracy and speed. If you want to just do this as like a learning exercise and you don't really care about the leaderboard, feel free to just take your time and just be accurate. But if you do want some friendly competition, feel free to pace yourself and try to be quick. So with that said, let's get on over to the game. All right, so I hope you guys followed all the instructions with the incognito window and signing up for the game. So now we can get started. We're going to go over here, click BigQuery Quick Start command line. And before we click Start Lab, let's just look at the overview real quick. Storing and querying massive data sets can be time-consuming and expensive without the right hardware and infrastructure. BigQuery is a serverless, highly scalable cloud data warehouse that solves this problem by enabling super-fast SQL queries using the processing power of Google's infrastructure. So simply move your data into BigQuery and let us handle the hard work. You can control access to both the project and your data based on your business needs, such as giving others the ability to view or query your data. And you can access BigQuery in a variety of ways using the console, the web UI, a command line tool, which we'll be using today, a variety of client libraries for Java, .NET, Python, and there are also a variety of other solution providers that you can use. And the main goal of this lab is to teach you guys how to use BQ. which is a Python-based command line tool to BigQuery to query public tables and load sample data into BigQuery. So you guys probably already set everything up. Yeah, just make sure you're in an incognito window, have a Chrome browser is recommended. And yeah, let's get started. So we're going to click Start Lab. Confirm that I'm not a robot. Hopefully I can pass this. Okay, good. And yeah, now we have credentials. We have a username, password, and GCP project ID, which are all custom generated for each of us. So let's go ahead and open the Google Cloud console. We can copy the username. Now let's copy the password as well. So this. We don't need to do any of that. And yeah, let's just ensure that our project ID is the same as the one we see here. And it looks like it is. That's good. Let's agree to the terms. And we can get started. So we already did all this. Now the next step is to activate the Cloud Shell. To do that, we go back to our Cloud Console and click this button up here. So this Cloud Shell is like a bash. It's based on Debian, which is a Linux distribution. And so a lot of the Linux commands you might already know will probably work here as well. This will take some time to provision everything. And then once that is finished, we can go ahead and use it. It also comes with 5 GB of free home directory storage, so that's pretty cool. So yeah, let's get started. If we want to list the active account name, we can use the gcloud command line tool, then auth, then list. So let's go ahead and do that together. And let's just authorize that. And cool, we see our newly created account over here. Yep, that is what we expect to see. Now let's list the project ID with gcloud config list project. Yep, so that is our project ID. All right, let's get started learning how to use BigQuery. What we'll do first is examine the schema of a public table. So Google Cloud Platform comes with a lot of public data sets that we can use to practice BigQuery. And the one we'll be using today is Shakespeare, which contains an entry for every Shakespeare word and every Shakespeare play. And to examine the schema of the Shakespeare table, we're going to run bq show BigQuery public data samples.shakespeare. This first part here, show, is the action. This next part is the project that we're accessing. This is the public data set. And this is the table. So let's go ahead and do that. BigQuery show BigQuery public data samples.shakespeare. And this will show us the schema. It shows the total number of rows, bytes, and the columns that we have access to. So if you ever need help with any command with BigQuery, you can write BigQuery help and then the action name, or you can run just BigQuery help in general to see all of the commands. So let's go ahead and run BQ help query, because that is what we'll be using first. So yeah, this gives us a lot of useful information. So let's run our first query. The basics of running an SQL query with BigQuery, it just comes down to this: BQ query, and then the SQL statement in quotation marks. Or you could use other types of quotes, single quotes, it's up to you. So first we're going to query the number of times the substring raisin appears in all of Shakespeare's works. That's an interesting word, right? Raisin, you wouldn't expect Shakespeare to use that word, but we'll see how often that comes up. So we're going to run BigQuery, BQ query. We're going to use this flag here. So BQ query use legacy SQL equals false, so that we use the latest version. And then we're going to write select word, select word, some word count, and we're going to name that count. Yep. And so these are the columns we're selecting, and this is where we're trying to get it from. Again, this is the project ID, this is the public data set, and this is the table. And we're going to need this in these special quotes. So from this, and we want to only choose the columns where the word is like raisin. So let's copy this condition here, where word like raisin, and we're going to group this by word so that we can put duplicate columns together. And let's see, group by, I think I put that together or something. Let's copy this just in case I messed up somewhere. Yeah, so it is running the query, and we have words here and counts. As you can see, these aren't necessarily raisin itself because we're looking for substrings or words that have substrings which equals raisin. And yeah, we can see the results here. So let's check our progress. This is a checkpoint, which you will see a lot of when you use Cloud Hero. And let's just ensure that we pass that. Good. If we search for a word that isn't in Shakespeare words, no results are returned. So let's just ensure that that is the case. We're going to run BQ query select word. Oh yeah, we need the flag. Use legacy SQL equals false. Select word. We need the counts this time, but we will need this from that. And we only want to choose it where the word equals huzzah exactly. Sure, that's good. So let's see. I think this flag I didn't put in correctly. Yeah, I was supposed to use underscores. Okay. Okay, so it says that it is done. And yeah, there we go. We didn't see any results there because Shakespeare did not use huzzah in his plays. So let's create our own table, but in order to do that, we're first going to need to create our own data set. So let's take a look at all the data sets in our project first. So BigQuery ls. That should give us nothing because we did not have any data sets just yet. Now let's run BigQuery ls BigQuery public data. And if you remember that, that is the sample project that we are using that has access to a bunch of data sets that we can use. So yeah, we can use all of these to test our SQL. So now let's create our own data set. What we want to do is create a data set of baby names that we can later query from. So let's do BQMK baby names. And yeah, successfully created. Cool. Let's check this checkpoint here. Cool. Now let's run BQLS again to make sure that it was indeed created, and it was. And now let's upload data. Let's populate our data set. What we're going to do is wget this public file here, which has a list of common baby names from different years. Cool. Let's run ls. And yeah, we should see that we have names.zip and this file that comes standard. Now let's unzip that file and just dump its contents into the local directory. Yep, now we have a whole bunch of files in our local directory. So now what we're going to do is load one of these files into our data set. The BQ load command creates or updates a table and loads data in a single step. And the arguments we'll need are the data set dot the table, then the file that we're going to use, and then the schema, which specifies the columns in the SQL. So we're going to do BQ load. We're going to do baby names. That's our data set. We're going to name our table names 2010. And the file we're going to put is year of birth 2010.txt. And here's our schema. We're going to use name, which is a string, gender, which is a string, and count, which is an integer. So let's run that. Cool, upload complete. Let's check this. Nice. So now let's list all of the tables in our baby names dataset. Just see that we have names 2010 over here. Cool, that is what we expect. Now let's run BQ show baby names.names 2010. Baby names.names 2010. And we expect this to give us the schema of our new table, and it does. Cool. Now I think we are ready to run some queries. So for our first one, what we want to do is find the top 5 most popular girls' names in 2010. So to do that, we're going to do BQ query, and our SQL statement is going to be select name, columns name count from. We're going to use our dataset.table. And we only want to choose the ones where the gender column equals F. And we're going to order this by count, using the count column. We want this to be in descending order so that we get the top 5. And we want to limit this to only the top 5. And let's see, error. Did you mean name? Yes, I did mean name. So let's change that real quick. Cool, so the top 5 names in 2010 are Isabella, Sophia, Emma, Olivia, and Ava, or Ava. And cool. Now we want to find the top 5 most unusual boys' names. So to do that, we're going to run a very similar query, except we want the gender to be male. We want this to be in ascending order so that we get the bottom 5. And we want the limit to be 5. I believe that's all we need to change there. Cool, so we get these names as the top 5 most unusual boys' names. And the reason these the counts are 5 is just a coincidence that the data that we're using, it omits all names lower than 5. So cool. Let's check our progress. Yeah, we did it. All right, so we are almost done. Let's just take a little quiz here. So below are some multiple choice questions, answer them to the best of your abilities. So you can access BigQuery using, what we did was the command line tool. We also learned that we can access it using the web UI. And there are a bunch of client libraries that we can use, so cool. Which CLI tool is used to interact with BigQuery service? What we used was BQ. Cool. So now we're pretty much done. We just have to clean up our workspace. So to clean up, we need to run the BQ RM command and remove our newly created dataset. And if we add the -r, it's recursive. So BQ RM -r baby names. Yes. Okay. Removed. Check this. Looks like we have not completed. Let's see what we did wrong here. So we did delete it. Okay, cool. So congratulations. Now you can use the command line with BigQuery to manipulate data. So we finished our first part of this lab. And to finish your quest, you can finish the rest of the parts, the other 3 remaining sections. If you want to learn more, feel free to use this resource here. And you are now well on your way towards gaining Google Cloud training and certification. So congrats, guys. We can now end this lab. I'm not sure if it instructs us to do so, but yeah. And cool. Let's check the leaderboard here. And yeah, there I am. A bunch of you have finished before me, so you're higher than me. Yeah, that's about it. Let's go on back to the slide deck now. Cool. So yeah, to wrap things up here, now you know how to start and end a lab, and we've walked through the lab environment together. So let's just review how you can see your score in the game. The score tab represents how well you are doing, as we just saw. It's on the right side. And yeah, that's also where you can see the leaderboard, or leaderboard is in another area. But if you'd like to see how you rank up against other people, you can see the top 50 scores as well as your score. And the GCP console has a few areas you should probably know about too. As you've seen, you can launch the Google Cloud Shell from the top right. You can also access a bunch of other GCP services by using the drop down on the top left. You can also search for services there. And yeah, there's plenty more that you can do as you explore Google Cloud Platform. There's also additional support that is available if you have any trouble on the bottom right of the screen. And we have 24-hour support, so feel free to contact us if you need any help. And finally, you can always go to Google for help, or you can go to cloud.google.com for some helpful documentation. And that is about it. Thank you guys for joining us. After the game ends, the top scorers will be contacted by email, and feel free to keep an eye on the leaderboard for the winners. However, for doing this on a Saturday and showing your desire and initiative, you are all winners to me already. And just a final plug here. If you want to see more events like this, feel free to join our community chapter at the University of Virginia by scanning this code, and follow us on Instagram, check out our website. Yeah, I'll hand the mic over to Samia now.
Also, if anyone is interested, you can also join RamDev at VCU. It's combined with the Google Developer Students Club at VCU. And yeah, here's the Instagram and the website. Predominantly use the website in Slack, so please do check us out there. Yeah, that is all. Thank you so much. You are all cloud heroes.